The number one characteristic of the project here at the Mississippi River that makes it unique based on things we've done in the past is that we're working with a much more representative river than ever before. We have done this several times in the past, but always at the Suwannee River in Georgia, which is a black water stream with a lot of organic matter and not much inorganic matter, and therefore not very representative of rivers in general. The scientific community would like to have a similar material from a much more representative river. And in the United States, it would be hard to find a more representative river than the Mississippi.
The source of the river is in northern Minnesota at Lake Itasca.
It's the largest terrestrial river in the United States.
The unique thing about Minnesota with respect to the Mississippi River, it's up on the upper end of the Mississippi River. And it flows through several medium-sized communities. It offers an opportunity to get a sample from a river that supplies water to a major city.
And by producing this referenced sample, we're going to allow scientists all over the world to study this terrestrial DOM material.
Rivers and lakes have always been underestimated in the global carbon cycle. We're seen until, I would even say, 3 years ago as merely transport units, transport terrestrial organic matter from the soil to the ocean. But now it is clear that physical transport process, this material itself, is chemically altered extremely much and extremely often.
Chemically, it presents an interesting challenge for me, and of course that's attractive to any scientist to work on something new and different. And the challenge lies in the fact that this river at Minneapolis has a relatively high concentration of natural organic matter, which is our goal. But mixed with it is a relatively high concentration of inorganic salts, which we don't want. I have previously developed a technique for isolating very small amounts of organic matter in the presence of huge quantities of salt by isolating organic matter from ocean water. Well, this problem is not as challenging as ocean water, but as rivers go, this is the most challenging project that we've undertaken. The standard and reference collection is housed at the University of Minnesota in St. Paul, and two of the members of the board of the International Humic Substances Society are faculty there.
We've been functioning both as a repository and a distribution center for humic materials, and as a forum for scientists to come together to share their research results.
Well, the IHSS was founded in 1981. At one point, we had about 1,000 members of the society from all over the world.
Working with them, it just seemed like a really good idea to take the sample here in the Minneapolis-St. Paul area. One of those professors, Ray Hozalski, has research collaborations with this particular facility.
All water utilities, including Minneapolis Water Works, are concerned about natural organic matter because of its impacts on drinking water treatment. In the case of Minneapolis, fouling of membranes used for water purification and water filtration.
We're trying to collect a few 100,000 liters of water from this site on the Mississippi River.
The general idea is to take raw, unprocessed water from the Mississippi River, to which the treatment plant has done absolutely nothing. We can see where the plumbing brings the raw water to us and where we boost the pressure of the water up to a level that will make it possible for us to get that water through our filters.
It's being pumped into our filtration system, and this is removing any bacteria, any particles, because we're just wanting the dissolved organic matter. One challenge was to filter as much water as we needed for this project, and so we have 6 series of filters. You're each able to turn them on and off so that you can change filters without interrupting the process.
And the water entering that filtration system goes through a 1 micron filter and then immediately through a 0.45 micron filter, at which point we consider it to be filtered.
All the filtered water combines into a single pipe that goes through a flow totalizer.
The filtered water then passes into a large processing tank. So we run the sample pretty much a full day of squeezing and concentrating the sample by reverse osmosis, and we wind up with a solution that's perhaps 70-fold concentrated and pH 6.5 or so. We then want to move that sample to the other side of the lab space where we're working.
I'm actually operating the coupled reverse osmosis electrodialysis system. There is a concentrate tank and a diluate tank. And the diluate tank holds the things that we're taking the cations and anions out of. So our sample gets loaded into this diluate tank. And through the process of electrodialysis, all the small ions get moved out into the concentrate tank, which is the one on the right.
We concentrate it by taking away water. The technique for removing that water is known as reverse osmosis.
I have our permeate water, the Mississippi River water, and the finished product, basically. The bottle in the direct middle, which you can see has a brownish, greenish tinge to it, is pure Mississippi River water. And this possesses the organics that we're looking at and the same materials that the water treatment plant wants to get rid of. So this is what we're starting off with. On the left, you actually see this very clear bottle of water, and this is the permeate water we produce via the reverse osmosis process. This is basically the clean water we squeeze out of the solution to concentrate it. And on the right you see a very dark, muddy looking solution, and this is our finished sample. This is taken directly out of the end of the electrodialysis process. This has been concentrated 200-fold from the original river water, and as you can see it has a very muddy black color and looks nothing like anything you'd want to drink.
At that point, we have a largely desalted sample that is about 210-fold concentrated compared with the original river water. So the 2 carboys that we carry away at the end of the day represent about 400 carboys of the original river water.
The concentrate was put into 5-gallon carboys and brought over to a cold room at the University of Minnesota.
When we're finished with the project, we'll go over to that cold room and we'll get all of the bottles of sample that we have processed and move them back to my laboratory at Ball State University.
The team processed about 140,000 liters of Mississippi River water and returned to Ball State University with about 1,200 liters of concentrate.
Once Mike has processed it, it's brought to a freeze dryer, and we get the dried powder and send it to the University of Minnesota, right here in this laboratory.
We expect to have a yield of about 3,500 grams of natural organic matter, dried powder, and that represents more than 85% recovery of the organic matter in the original water sample.
Scientists all over the world will be contacting IHSS and ordering small quantities of this sample for use in their research.
And they're going to work on things like photooxidation, disinfection byproducts.
Someone like myself to exactly compare my experimental methods with another scientist in another country or in another state where we don't have access to the same rivers or lakes. We could not otherwise be able to know that given the same sample, we get the same answer.
And these are all problems that really face the world for water quality.
They are constantly doing chemistry here in this plant to try to remove the organic matter. And whatever the scientists around the world learn while they're working with this sample has the potential to be beneficial to this process here.
This Mississippi River sample will be added to our standard and reference collection. This collection includes natural organic matter isolated from the Suwannee River, as well as from a reservoir in Norway via reverse osmosis, from Pony Lake in Antarctica, as well as from a prairie soil in Illinois, a peat soil in Florida, and leonardite in North Dakota. These materials are available to researchers around the world via the IHSS online store.